we look at mixtures and pure substances, one of the things that you can do is add water. And when you add water, you're actually making a mixture as well. But sometimes different things happen. I just wanted to talk to you about what it means when you add water to something and how that affects it. So we've got some water, and add it to my particles. You can see that they're still sitting down the bottom. You can still see them really easily. I could separate them. It's obviously a mixture. I could separate by filtering or decanting, lots of different ways. If the particles started to fall apart and pull apart in the water though, we get to the point where we can't see them anymore. So these particles don't break apart in water, and we can see them the whole time. They're really easy to see. But if they were able to break apart with water, they get to the point where you can't see them anymore. So if we cut them out and we use something like sugar, you've probably seen sugar when you put that into water before. To start with, you can see the particles, and then gradually they get further and further apart until they seem to disappear. Now the particles haven't gone anywhere else, they haven't changed into a new substance. All that's happened is they've just got further and further apart in the water. When I put them into a glass somewhere else, you can't see any particles left at all. It's perfectly clear all the way through. But if I taste it, what do you think I'll find? I can taste it. The particles are still there. They've just been separated so far apart that you can't see them anymore. And what we call that is dissolving. And in this case, the sugar has been dissolved in the water. Now we have a name for what we've made. That mixture is called a solution. And we've also got a name for the part that was dissolved. The sugar is called the solute. And the water, or the part that was a lot bigger to start with, that's called the solvent. So the solvent is water, the solute is sugar, and at the end I've made a solution of sugar and water, or a mixture of sugar and water. I come back to the marbles that I had. They were not able to dissolve. Look at my water there. I know they're not going to dissolve, I know. I might use the ping pong balls. In this case, we've got a solvent, but when I add my solute, it doesn't dissolve. So we have a name for these particles. They're not a solute at all. They're called insoluble particles. So things that don't dissolve are called insoluble. Things that do dissolve, like sugar, are called soluble. So there's quite a few words there that involve solutions and mixing and particles. Might need to make some notes about which one is which and which one is spelt which way and what they actually mean. So I've got my solution here. What I'm going to do is test a whole range of different things to see if they're soluble or not. So, same sort of things that we might have already used in the kitchen and tested. Things like flour, margarine, rice. And one thing that is interesting to have a look at, so you need to try and add some of this, maybe some melted butter, maybe some oil. So this is my solvent, and I'm going to see if when I add something to it, it dissolves. Let's see if it will mix to make a solution. Now, to show you what happens when I add some oil to my water, you might have seen this before. As I add the particles, we have a situation where it's not dissolving, it's not a solution, and it's not mixing. So we would say that the oil is not soluble. And there's another word for this. If something's not soluble, it means it's not quite unmixable, but the word is similar to that, immiscible. So when things don't mix together, we call them immiscible. And you'll see quite clearly that there are two layers here. Now, looking for a bit more of a challenge as you look at mixtures and solutions, here's an interesting one that you can impress people with. What you need is some milk, you need some food colouring or food dyes, and you need to be careful with this because it really does spill in lots of places and ways. Now, if you don't do anything to mix it, don't give it any energy, and you put some of your drops of food dye here, it doesn't mix very far, it doesn't dissolve very well, and it doesn't spread very much. So I'll just put a few drops on here, and I'm lucky I've got all manner of colours here to choose from. So going with all the different colours. You see they haven't really moved and connected onto each other yet, have they? Alright, last one, some green. Now remember I said that detergent makes an excellent emulsifier. Well, it does in milk as well, because milk has some oils and it has some water. What I'm going to do is just do a single drop of detergent right in the middle there, and we'll just have a look at what happens over the next few minutes. Your challenge, not just to do this and impress small children, but maybe make a video of it, and then with the voiceover as you explain what's happening, see if you can explain which parts are soluble, which parts are the solvent, solute, and what the detergent's doing here. It's still going. I could watch this for hours.